Hey, stoichiometry, isn't it great? Hey, we're going to show you how to do practice problem number one, or excuse me, practice sheet number one, but problem number 4. So we need to change this right here, change this to a 4, and we'll go ahead and get started. So on your practice sheet, we have this one right here. It's number 4. It's going down. So if we read it, it says, if sodium reacts with oxygen, it will create sodium oxide. And then how many grams of sodium do you need to produce 42 grams of sodium oxide? So the first thing we need to do is we need to go ahead and write our skeleton equation. You can't do this without writing the skeleton equation. And again, as always, for my class, you need to make sure you show your work. So we're going to write the skeleton equation. We're going to balance it. Then we're going to go ahead and start the stoichiometry using this number right there, which again, 3 significant figures. So it means our answer needs to be in 3 significant figures. So let's go ahead and start write the skeleton equation. So it says if sodium reacts with oxygen. So down here we're going to put down sodium is Na. Hopefully you know that. If not, you got to go back to your periodic table, pull up your periodic table, look at it. So sodium is going to react, and it's going to react with oxygen. Now, one thing that we need to do when we have any element by itself, we have to look and say, is it diatomic? You should know the 7 diatomic elements by now. If not, look at your periodic table. Remember, they make a 7 on the periodic table. Then you have to add a hydrogen to that. So if we go to the periodic table, we'll look at it. Here are the 7. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then hydrogen, which is right up here. So those are our 7. So if we look at sodium, sodium's right here. So sodium is not one of them, but oxygen is. So let's go ahead and go back to this. And so sodium's not, so oxygen is diatomic. So that means we have to give it a subscript of a 2. Now, that is going to yield sodium oxide. Now remember, sodium oxide, I'm giving you the name. It's not just NaO. We have to go ahead and figure out the nomenclature of this. So let's look at it. First of all, we know that sodium's in column 1. So the metal tells us that it's a type 1. So what column it in is, what A group column, tells us the charge. So if I go right over here and I just give you the charge of the sodium, I know that the charge of sodium is +1. Okay, but what's the charge of oxygen? Again, for us, we can use our periodic table, and I'm going to click onto the periodic table, but I'm going to do something a little bit different with that. I'm going to also scroll down to page 14, and we will see right here on page 14. We know that sodium is a +1, but oxygen is a -2. Now again, it's in column 6A. It needs to get to 8. It has 6 valence electrons, so you got to add 2 electrons, which those are negatively charged. That's where we come up with the -2. So let's go ahead and get out of that, and we know that that's going to be a -2. Now again, the plus signs or minus signs can be on the opposite side, which most of the time they are. Because they don't cancel each other out, what do? We use the crisscross method. So we're going to go ahead and put a 2 right here with this one, and we're going to put a 1 over here with this one. So, and we can go ahead and we can make them subscript if you want to. And I like putting them in here just because I know what it is. So now I have the symbol for sodium, which is Na, with a 2, and then oxygen with a 1. So we're going to come right over here and we'll put Na with a subscript 2, and then we're going to put oxygen 1, but we don't write that in. So there is our unbalanced chemical equation, or we, as I like to call it, a skeleton equation. It just has the bare bones. It's not filled in yet. So we need to go ahead and fill that in. So the best way to do this is to go ahead and put in all the elements that we have on each side of the equation. So I have sodium and oxygen. So, and then I have to put in how many I have of each one. So we have 1 sodium and we have 2 oxygens. So on the other side, okay, I have sodium right here, we have Na, but we have 2 of them. Now where did the 2 come from? This subscript right here tells me I have 2 of them. So we're going to put 2 down, and then we're going to tab over and do our oxygen. So our oxygen is going to be how many? Not this 2, there's a 1 down here, so there's only 1. So I have 2 sodiums and that I need to fix. on each side. So let's go ahead and do the elements that are not by themselves first. So let's go ahead and do this. I have this one all by itself. This one's in groups of 2. So let's just change the oxygen first. So I have 2 on this side. I need 2 on this side. So I'm going to use, we can only change coefficients, if you remember that. So we're going to put a 2 there. That 2 tells us now we have 2 oxygens. So I have 1 with a subscript times 2 is 2. So that changes to a 2. Okay, we can get rid of that. Now we also change, because we changed this whole molecule or whole compound, we got to change everything in it. So our sodium now is not 2, but I have 2 times 2, which that means it's 4. So we're going to go ahead and get rid of that also. And now what we can do now is we're going to chase it across. So now I have to put 4 on this side. So my oxygen, notice my oxygen's good, but my sodium is not good. It wasn't good before, but it's still not good. So we're going to have to go over here, and I can't change the subscript. So I have to change the coefficient. And so in the subscript is 1, right? It's not there, but we know that we have at least one of them. Okay, what times 1 equals 4? So we can go ahead and put a 4 right there. Now that changes that to a 4, and we can get rid of this. Okay, so now I have 4 sodiums on each side. Okay, so I have 4 sodiums here, and I have 4 sodiums here. I have 2 oxygens right here, so I have 2 times 1 is 2, and I have 2 oxygens right here. So there we go. There is our balanced chemical equation. We could write out the molar ratio, and that is going to be 4 to 1 to 2. And that's it. That's our molar ratio. The one thing that we always have to look when we do the molar ratio is we ask ourselves, is it in a situation where we can reduce it? Well, since I have a 1 already in it, we can't reduce it. So there's our ratio. So we go back to the question, and it's going to say, how many grams of sodium do you need to produce 42 grams of sodium oxide? So here's my sodium oxide, and we need to know how many grams of sodium that we need. Now it's a 4 to 2 ratio or 2 to 4 ratio, depending on how we're going to write that out. So we're going to go ahead and start our stoichiometry, and we are going to start with the number that's in the problem. So you say start with the mass in the problem. So here's our mass right there. We said it was 3 significant figures, so we're going to go ahead and write that out as 42.0 grams of sodium oxide. So sodium is Na. We know that we have to get a subscript of 2, and then we're going to go back with our oxygen. So there's sodium oxide. Now again, when we convert from 1 to the, we always put in our handy dandy times and a line. Now, because we're going to do this, we have to say what's equal to each other. Well, when we use molar mass, and that's next, we're going to convert from mass to moles. We use a molar mass. 1 mole equals the molar mass of that compound. So we're looking for something. We're going to look for the 1 mole of Na, our sodium oxide, and we're going to highlight this, or underline that. And then we're going to come down to the next one, and we're going to put that in, but that's going to be grams. So we have 1 mole, so we have grams of Na2. Okay, so we're going to put that in there as a gram. So but we got to figure out how many grams is it. So what is the molar? 1 mole equals the molar mass. So let's go ahead and calculate out the molar mass. So what is the molar mass of NaC? So the molar mass of Na. So we like to do this by go ahead and calculating out each element that's in there, and the amount that they have of each one determines it. We use the atomic weight. So we have sodium, and we have oxygen. Okay, we have 2 sodiums, Okay, and we're going to multiply that by the atomic weight. Now, I'm pretty sure the atomic weight is going to be 23, but we'll check that. And then we go to oxygen. We have one oxygen, and that's going to be multiplied by the weight of oxygen, which is 16. Again, we'll double check that. And that's going to equal. Now, again, this is how we show our work. Okay, so this should be 46, and this should be 16. Before I go ahead and do that, we're going to look at the periodic table. So let's go back to the periodic table, pull that up, scroll back up to our periodic table. And so we have our periodic table right here. There we go. Oxygen is 16. Sodium is 23. So we are good on that one. So let's go ahead and go back to this. And so now, in order to do the molar mass, we just add these two together. So let's get out the calculator. And we're going to take 46 plus 16 equals 62. So the molar mass of that is 62 grams. So that's what the molar mass is. So, and then we calculated it by adding these two together, our 2 sodiums and our 1 oxygen. So one molecule, or in this case, it's of the compound, one of this formula unit is 62 grams. So now we're just going to go over here and we're going to tuck that in right there. 62 grams. Okay, so now we have our, we have it converted to moles. Now I know that it's converted to moles because I have grams of sodium oxide on bottom and grams of sodium oxide on top. We don't have to worry about the numbers, so we're just going to get rid of our grams of sodium oxide on top and bottom. And again, we're getting rid of them because I have them on top and bottom. I can get rid of them, and they're not in the way to see where we're at. So now we're at moles. Now, how do I get from moles of sodium oxide to grams of sodium? Well, I have to go to the moles of sodium. So we're going to go ahead and put another, since I got to convert again, our handy dandy times in a line. Okay, and we're going to put on bottom. Now we have moles of sodium hydroxide. Now the only thing I have is I have 4 moles or 2 moles of sodium oxide equals 4 moles of sodium. So that's what we're gonna do it. So we're gonna go to the bottom, put this over here, and I am going to take that out of subscript or strike through, and we're gonna put down 2 moles of sodium oxide. Okay, we're going to get rid of that right there. I don't know why, I just don't want to put it in there. So we have it there. And then on top, we're going to put our moles of sodium. So this 2 moles of sodium oxide, 2 moles of sodium equals 4 moles over here of sodium. So we're going to put in 4 moles of sodium. And we'll go ahead and underline that. Now I can get rid of my moles of sodium oxide on top and bottom. So we're going to get rid of that. So we'll strike that through. We'll strike this one through. Okay, but I'm in moles of sodium, not grams of sodium. So now I got to convert back using, again, my molar mass. So we're going to put over here a times in our line, and we're going to put 1 mole on top. Remember, when we use molar mass, it's always 1 mole equals. Since I have moles up here of sodium, I got to put moles on the bottom of sodium. So we're going to put down 1 mole of sodium, and we're not going to strike that through right now. So we get that, and that's going to equal our molar mass in grams of sodium. Okay, so we're going to put down our grams of sodium. And what did we say 1 mole of sodium weighs? Well, 1 mole of sodium weighs 23 grams. So if I went over here and if I just said for sodium, I'm just going to do Na, and that's going to be 1 times 23 equals 23. So we know that we're going to put that in right there. So there's 23. We showed the work. We're going to go ahead and underline that. and then we can put our equal sign in. Now, one thing that we need to do also is we need to cancel out that last little bit because I have moles of sodium here, moles of sodium there. So we're just going to go ahead and get rid of that, strike through it on top and bottom. And now I only have one unit left, and that unit is going to be grams of sodium. So now what I have to do is convert from grams of sodium oxide to grams of sodium. I do it with my stoichiometry. So again, we're going to go ahead and do the math. Now the math says that we go ahead and we multiply by the top, we divide by the bottom, as always. Okay, and if we have a 1 in either one of those places, we don't have to do that step. So we're going to start out with 42. We're going to divide that by 62. Then we're going to multiply that by 4. Then we're going to divide by 2. Then we're going to multiply that by 23, and we should have our answer. Our answer should be 31.161. So let's just go ahead and do that. 31.161. Okay, let's double check that again. So let's double check it again. I always double, triple check, whatever you need to do. So 42 divided by 62 times 4 divided by 2 times 23 equals 31.161. Okay, now we needed to have it in how many significant figures now? Well, we look at the original problem and we see that there are 3 significant figures. So we need to put a line right here. The 6 says we do what? The 6 says we round up. So our answer needs to be 31.2 grams of sodium. So in order to get 42 grams of sodium oxide, I need 31.2 grams of sodium, which means we really don't need a whole lot of oxygen. So we go ahead and once we get done with that, we highlight our answer. And there we go. That's how we solve from practice sheet number 1, problem number 4. Hey, as always, go Mohawks. Nelson out.